Warm greetings to all our online participants and viewers. I welcome you to this prestigious session of keynote speaker of the Second International Conference on Unmanned Aerial System in Geomatics 2021. This session brings to you one of the distinguished personalities in the field of unmanned aerial systems and geomatics, and is going to be an awe-inspiring brainstorming, a delight to your intellect session. I now introduce you to our keynote speaker, Dr. Yongjun Zhang, Dean of School of Remote Sensing and Information Engineering, Wuhan University, China. Dr. Zhang has been engaged in the research of integrated photogrammetric processing of space and aerial multi-source remote sensing data, including intelligent processing of low-altitude imagery for a long time. He is responsible for the development of the first digital photogrammetric grid processing system for space and aerial remote sensing imagery with complete independent intellectual property rights in China, which was successfully applied to national major projects and various projects of geographic information, as well as in the quick response of serious disasters of Wenchuan earthquake. In 2015, the technology was transferred to ESRI Incorporation US, which is the first technology export with independent intellectual property rights in the field of surveying and remote sensing. In addition, Professor Zhang has published more than 80 academic papers in top-tier SAI journals. He holds 25 national patents of invention and 25 computer software copyrights, and is the chairman of the International Academic Conference PhotoGA 2017. I request Dr. Yongjun Zhang to share his scholarly views with us from his vast research and experience. Over to Dr. Yongjun Zhang.
Okay, thank you, Chairman, for your kind introduction. And ladies and gentlemen, good morning and maybe good afternoon, everyone. So my presentation is about technologies and applications on automatic photogrammetric processing of UAV images. First, I want to show you some backgrounds about photogrammetry in our school. Starting from 1978, we have already started the fully automatic mapping system research and development. It is called, which also maybe you guys know, it is one of the 3 famous digital photogrammetric workstations in the world, and it completely changed the production manner in both China and the world. So many analog and analytical instruments were taken into the museums when, after this system has occurred and commercialized. And during the new centuries, we have developed another digital photogrammetric grid system. It is fully utilize high performance parallel processing technologies, and it can automatically processing of satellite images and the 3D modeling with airborne LiDAR data and multi-view images. And it also has another main function about near real-time intelligent processing of UAV low altitude images. This is exactly what I want to show you today, is about how to process low altitude images. So my content of this presentation includes 5 parts. The first one is about the overview of low altitude photogrammetry. As we know, there are many kinds of low altitude flight platforms, include helicopters, small UAVs, and fixed wings, and also airships, and so on. All these kinds of platform can be used for photogrammetry. And there are many advantages of the UAV photogrammetry. For example, it can fly under a cloud, it's fast and flexible. The operation is very simple, and specifically, it is very low cost. But however, there are also some difficulties. For example, there in cities, there are many high buildings. It will have a very large projection parallaxes, which cause matching problems. And in some cases, the overlap between adjacent images has very large rotation angles. For example, this image pair has about 30 degrees of rotation angles. And in some other cases, there are some very large roll angles between because the small UAVs is not strong wind resistant. So when there are some strong wind, the attitude is not quite stable. So there are very large roll angles. And in some emergency cases, the flight paths may be very irregular. For example, this the red crosses, yellow crosses are the flight passes. You can see it's almost, we can call it free flying. So that is very complicated. And in some non-professional cases, there may be very short baseline and tall trees and with very high resolution acquired by UAV. For example, we can acquire 5mm ground resolution images by the helicopter, small UAVs. So all these cases bring very serious problems. So actually, our group started the research about low altitude photogrammetry was in 2004. That's about 17 to 18 years ago. We, at that time, fixed wing UAVs are not very popular. So we used initially we used the left part, the airship, flight airship, and we established some hardware configurations. That means we can use the airship to acquire imagery, and in the vehicle, we can process it on the spot. So this is the concept of space and ground integrated UAV photogrammetry platform. We can just process all the data on site after the UAV has landed. Here are some examples of how to use flight. This is a airship taking off vertically. You can see some video. It was acquired during 2005 and 2006. Yeah, this is the first video, and then is another. The airship can also take off by forward heading. Yeah, it brings the camera outside the ship, so we can take photos and all the images automatically when it flies in the sky. And this is the configuration. We have a airship, and we have control systems. We have 3-axis platform and the camera and the remote control system. So the right part is the flight path of the airship. It is auto-piloted, fully automatically piloted without any human control. So this is a brief introduction about the background. And there are some key technologies of UAV photogrammetry. So the first one is about multiple feature robust matching of images. Here, we proposed a new concept that is called generalized point. So it is the general name of feature point, line, free curve, and other geometric features, because all these features can be regarded as the combination of continuous points in the image. So in this case, we can transfer the precise a single feature matching to multiple features. For example, point, intersection curves, lines, and so on. And also we can transfer sub-pixel precise correspondence to overall matching. For example, we can know there are two lines which corresponds the two same object line. So this is crosses are very precise correspondings. In this case, we can use lines for image matching, which is more stable to find correspondence. There are some interesting technology and the available commercial software methods. For example, the left part, there are many matching image points, but the right side, the traditional software can only match a few correspondence points. Here is another example of the comparison of urban areas between new and old methods about the image matching. Here is the automatic matching result of large rotation angles. You can see all the corresponding image points are nearly correct. That means we have some experiments and more than 99% of images are correct. Points are correct. Actually, there are some features, other features can be used for image matching. For example, circles, rectangles, besides lines. All these multi-features can provide more reliable observations for block adjustment. As you can see here, robust block adjustment is more stable than purely use only corresponding points. Multiple feature can make the strip very straight, but the traditional one you can see is bending. So this is the advantage of block adjustment with multiple features. There are some experiments about UAV images. Here have a text support area, and you can see here the upper part of this red circle. You can see there are about 600 distortions with only image format is about 4,000 by 3,000 pixels. It means the lens distortion is very serious. So in this case, block adjustment must eliminate the lens distortions. Here are original images. And in some other cases, for example, this case, there are about 12,000 images and 60 million image points. So many famous international software failed in this case because the flight path is south to north and also east to west. So it is memory consuming. But our new technology only use 8 hours and the RAM usage is only 6 gigabytes. So it's quite fast as compared to some other software. There are some other results about low altitude photogrammetry with respect to the accuracy. Here are images acquired by airship, as I show you above, and with a Canon 1DS Mark III camera with 24 millimeters lens. Here are flight passes and the checkpoints and control points. So the ground resolution of these images are about 5 centimeters. As you can see here, we use some control points and most of it are checkpoints. The height accuracy is very good. It is better than 3 centimeters. This result was obtained in 2006. This is also map of this test error. and I have to move fast. And another test field about the aerial camera. Actually, it's not a UAV camera. The ground resolution is about 10 centimeters. It has differential GPS on board, and we only use 4 control points with the triangular shape, and all other shapes are control points. As you can see, compared of the 10 centimeters ground resolution, the height accuracy after block adjustment is about 4 centimeters. As you can know, this result is also very, very good. This is also image of this test field. And after that, we can do the surface model extraction after the aerial triangulation. So this technology, we use only image matching without geometric constraints. The first concept is we use the known points to guide the unknowns while constraining and evaluating the matching result. That means that after the aerial triangulation, all these triangulated points are seed points. It is treated as known, so to guide the expanding of the dense matching. So this strategy is very, very fast. As you can see, we have some comparison between our method and the famous HGM. Our method is 5 times faster than HGM, but the result is quite similar. This is some results of the dense image matching. And here are some results about our campus in Wuhan University. It's a 3D view and with some textures. Also, feature lines are also used for the dense image matching. As you can see, here are some good results about the feature line matching for reconstruction of the 3D buildings together with feature points. This is some results about a digital surface model through point and line feature matching. Here are some other results about a campus, university campus in China. And here are some results about the river. As you can see, all points in the river are also quite flat without any noises in this case. So the fourth key technology are large-scale orthophoto mosaicing. As we know, UAV images are has a very high resolution. The difficulties is it covers a very small area for each image. So we have to mosaic all the images together to generate the orthophoto. So we proposed a new concept to mosaic the images with a digital surface model and also digital elevation model. So we use the differences about the two models to mosaic them together. Here are some comparisons. The blue ones are initial mosaic lines, and the yellow ones are currently commercial software, the results. As you can see, some buildings are cut into two images, so the mosaic lines are not good. And the red ones are our results. You can see all of these buildings have been successfully awarded. So this is a result of the whole area of our method about the DP. We called it DPGrid. The right part is the mosaic result of foreign software. The results are similar, but in some cases, our results are better. We also have necessaries to do the color correction about the images. As the left part is the result of also image without color correction, and the right part is after color correction. We do the radiative aerial triangulation for the color correction, because in the same location, different images should have the same color information. So this is our error function. The fifth key technology is about the multi-core and CPU and GPU parallel processing. So we established the multi-computer, multi-CPU plus GPU strategy, and we can also hybrid personal computer and the workstation and the server together. And we also can use single mobile computer. So these configurations are very flexible, because our parallel processing are fully developed by ourselves. It is not related to other commercial software. So our configuration is very flexible. And we can finish the automatic fully process our about 200 images within 5 minutes using a single computer. This is our time efficiency for processing. So the third part is about the applications of UAV images for large-scale mapping. Here are some results. 400 high-resolution images acquired by UAV, but it has 45 degrees of rotation angles, which is very serious. This is a result of some famous foreign software. As you can see, the results are completely wrong. This is our result. The first upper part is the image points inside the strips, and the lower part are image corresponding points among different strips. As you can see, here are the also image. It is quite good without any human interaction. Here are some other results about 1 to 500 scale mapping without any control point. There are about 500 images with about only 4 centimeters ground resolution. And here are the 3D view. We only use GNSS for control points. All the 41 checkpoints are used are not used in the triangulation. So the result is quite similar to foreign software. That means there are some about 10 centimeters of systematic errors, because the camera is not pre-calibrated. This is the problem. But after the pre-calibration, the result will be very good. Here are some other accuracy verification about the DJI Phantom 4 RTK UAV. As you can see, there are also very serious systematic error in height. It is about 7 centimeters. So precise calibration is very necessary. Here are some results about maximally 800 pixels of lens distortions. So after we use a few control points to do block adjustment, all the checkpoints are very good. It's about only 3 centimeters height accuracy with regard to 5 centimeters ground resolution. So that means if we use a few control points, all UAVs can obtain very high accuracy. Here are some other applications about first response in natural disasters. Here are some flight path footprints of Wenchuan earthquake as you guys may know, in 2008, there was a very serious earthquake in China. This is a flight path. And in this case, we have done fully automatic processing of all the images. It was called free flying photography. It was in the first time. At that time, no commercial commercial software can deal with this kinds of data. So our DPGrid is the only unique one. So before block adjustment, the vertical parallax is about 16 pixels, and after block adjustment, the vertical parallax improves into about half pixels. So it is very, very significant. And here is a comparison before traditional method and the new method. And you can see the mosaic lines are very, very good after block adjustment. And the processing efficiency is at least 10 times higher than traditional methods. So here are some results about the also photo of the disaster area. As you can see, the white house has no image data because the fixed wing airplane, when it's turning around to take photos, the Nadia view has no images. It is reasonable. This is a snapshot of the barrier lake. It was the very largest barrier lake in the disaster area, and we sent some machineries to dig in all these earths. And the final part is about the international collaborations with ESRI. That means as we know, imagery is also one of the cores of GIS. That means GIS software also use imagery to generate the information and also for the interpretation of the spatial data. So in this case, if we join image and map together, the effect is 1 + 1 is more larger than 2. So in 2015, our DPGrid technology was licensed to ESRI to promote the global commercialization. This was the first technology exported in the remote sensing field in China. Of course, it was licensed before the trade problem. So our technology called also mapping tools, it was released in December 2016. This has the functionality of fast adjustment, generate digital surface model, and generate also photo for both satellite, aerial, and also UAV images. So it's a full chain processing technology. Here are some results about the test results. In this example, there are about 1,200 images acquired by UAV. It's quite irregular and repeated strips. There also exist some water errors. So commercial software, the world famous commercial softwares all have failed in during this test. Here are the 3D view of the block adjustment result. As you can see, the triangles are the camera positions when acquiring images. As you can see, it is very, very irregular. And here this is this triangulated object points, the 3D view. As you can see, here has a water area, water body that departs the test field into 2 parts. This is the finally generated also image after block adjustment. Here is in large of the result. We can see the mosaic lines are aligned very, very good between adjacent images. So there's another test field which have about 2,000 images acquired by UAV. It was a very high mountainous forest area, and also all the internationally famous software failed in this test data. Here is a 3D view of block adjustment result. As you can see, the maintenance error is quite high. Has the also image of the data set, as you can see. This is the initial mosaic lines of quick also image for color correction. As you can see, all the rows are connected very, very good. These are some other results about the maintenance error in this test field. And so basically, this is what I want to show you about our research achievements during past 15 years. And here's the brief conclusions. So based on the rapid development of new technologies, efficiency of obtaining low altitude UAV images is increasing rapidly. So our WHO group has more than 15 years of research experiences in UAV photogrammetry, and we have established near real-time processing capabilities. And more important, we are open to cooperate with all these colleagues in our planet. And I believe unmanned aerial system will achieve greater development in our geomatics. So finally, I want to make a brief introduction about our school. So our school is named the School of Remote Sensing and Engineering at Wuhan University. It was founded in 1956. Our remote sensing at WHO is now ranked #1 globally. So just a short advancement. We are now recruiting all levels of scientists and young scholars. So in the area of both photogrammetry, remote sensing, GIS, computer vision, smart city, artificial intelligence, global ALC, and also in ecosystems and so on. So if you guys are interested, please contact me in any time. Thank you for your attention.
Thank you, sir, for your presentation. We have some questions already listed. So
Okay.
with your permission, should I put them across to you? The first question is, would this unmanned aerial system be adaptable to different terrains? For example, high altitude with varied terrains?
You mean high altitude terrains?
Sir, high altitude terrains.
Yeah.
With varied terrains.
With vegetarians.
Yeah, with varying terrains, yes.
Yes. If you can acquire enough images, so the processing technology is not a quite difficult problem, I think, because we have encountered many difficult cases. For example, high terrains and high forests, and also very small overlap images. For example, there may be only 50% overlap between adjacent images. We have also deal with these cases. So I think it's not a problem for us.
Right, sir. Next question is, can we orthomosaic a set of infrared images captured by a UAV? Is there any open source software for the same?
Actually, there are some open softwares, but not from us. Our software is commercialized.
So there is a possibility.
You may see you may see some open software in the website, but our software is commercialized. And maybe if you guys are interested in, we can send you a license, and we can talk about how to cooperate together.
Great. So the attendees, you already have the contact details of Dr. Zhang, so you can contact him personally.
Okay.
And there is another question which asks, how stable was the airstrip in strong winds? I believe you mentioned it during your presentation. So how stable was the airstrip in strong winds?
The airship itself is quite strong. it can receive maybe 10 meters per second winds. It's not a problem, but the altitude maybe a small problem. It can fly. It can fly in the wind, no problem. But the quality of the imagery may be decreased.
Right. And we have the last question coming up, which asks, are there any camera calibrations that are needed while free-flying UAV for the purpose of surveying?
You mean? Can you repeat this question?
Yeah, the question asks, are there any camera calibrations that are needed while free-flying UAVs for the purpose of surveying?
Yeah. You have to do the pre-calibration. We have some softwares, and also many commercial software has this functionality. I think it is quite important to do pre-calibration when you do surveying.
Great, sir. We have another question, which is, how coverage area the most efficient for UAV mapping? How many number of photos? How many number of photos are required?
For UAV mapping?
For the most efficient number for block adjustment.
It has no. I think it has no limitation, but better less than 5,000 images.
It should not be less than 5,000 images.
No more than 5,000 images.
No more than 5,000 images.
Yes.
Great. And so what I can inform the attendees is that they can ask the questions, and if they have any other, and which will be answered later.
Okay.
Thank you so much, sir, for enlightening us with your views and sharing this information with us. And we already have your contact details. It has been shared with all the attendees, and they may contact you for any further queries.
Okay, no problem. You guys can contact me by email.
Email, sure, sir. Thank you so much. Thank you to all our online viewers and participants for being a part of this keynote session. We now end this live session.
Okay, thank you. See you.
Thank you, sir.